Hello everyone, I'm here to showcase a little project of mine that I've been working on for the past few weeks. And you probably can see it right now and do think that's a spectrum analyzer. Yes it is, it's an audio spectrum analyzer and it's very basic. This is just the view part, like the visual part. I made an application on my desktop where the FFT calculation is done, the fast Fourier transformation. That's actually just calculating which frequency, which amplitudes, etc. And just sends it over to the Arduino and it displays it. I'm a little proud of this. It's my first project where I'm creating my own PCB. As you can see, it's like a custom PCB thingy. I'm sorry for the flickering, my lamp is really not helping here. And as you can see, it's like a grid of 16 rows of 12 LEDs using these square, whatever they are called. They're beautiful. I like these kind of LEDs. And it basically works by using shift registers. I can't pronounce that very well, I'm sorry. They're just connected using, well, 4 wires actually, and then the power and the ground. So actually for everything, you need just about 7 wires, like 3 for the shift registers and 4 for the grounds, and I'm going to explain why. As you can see, there are 12 LEDs per row, but the shift register has just like 8 output pins. That means that I have to multiplex them because otherwise I won't have enough pins to use. The first four outputs are like shared between the bottom 4 and the top 4 LEDs, and you just switch between them. And even more, you switch between 2 rows. You have like these 2 rows are just done by 1 shift register, like you can see there. That's about it. It's just really simple. I'm just gonna demonstrate it. Just one more thing. This thing is obviously not powered through the Arduino. There's way too much current to be drawn through the Arduino. I think there's some protection on it, so it won't overcurrent or anything, but it will just like, the LEDs will be really low brightness wise. So yeah, I just basically use like a separate USB thingy, and I will connect it here. It's really difficult for me to do with one hand, so I will be back in a minute. Finally back again, and I've connected everything up, and as you can see I've moved some things around because it's a few days later. Useless information, I know, because this is just basically the same video and nothing has changed on this project itself. Just the timing didn't go well with me and it got dark, and this camera is shite, so I can't film in the dark. So, back on topic, everything is connected, everything is working. I don't think, yeah, the LED is lighting up right there. So let's start up the application that I made for it so that it can show the spectrum analyzer. And it shows up on my other screen. There it is. Now COM7 is my Arduino right here. So you select it just by pressing 1 and pressing enter. As you can see, it's turning on just perfectly fine. Next thing what you do is selecting the speakers you want to listen to. And that's 23 in my case, and then you have here like a virtual spectrum analyzer just for me for debugging purposes. Anyway, so I have multiple modes. You can select them with the number key. So we have 0 is real mode, 0, 1 is so this is the real mode, so directly without decibel conversion or whatever, and without the percentage, because 12 bars, 12 LEDs, I'm using percentages in the second mode. Let's get started. I have like this song here. Alright, switching to percentage mode. listening to my speaker so I can pick up whatever I want and just play it back. Or pick something entirely different. Like baby metal. Alright, that's about it. And as you could see, there are some LEDs still broken right now. I'm planning to fix them in the future. It's not really bothering me right now, and it's going to be painful to do to fix them. I will show you the back of this thing. I did it in the first part of this video, I guess. It's really a big ass mess. It's really bad actually. So if I have to resolder stuff, it's gonna be a pain. The wiring here is also garbage. It's just really bad stuff going on here. But this is basically how it works. You have just like all these shift registers just passing through bits and bytes. And you could expand them. That's how I designed them. So I could actually make another 2 of these and expand them. I'm not really sure how that's going to affect the speed. Obviously we have limitations about how fast you can push through bits and bytes. At the moment it's like doing it 240 times per second if I'm right. So that's quite a lot, quite fast. That's why it's quite fluid, and you could see actually really quick reaction to music, and that's what I really like about this, because when I look up spectrum analyzers, this is not a real, actually, like it's not represents real values like you would with normal spectrum analyzer. And if you look them up, you always see like a very slow reacting analyzer that really with this kind of metal music, for example, it's just like one solid block of light that's there and not really reactive to the music. And I like visualizing things, so it's not scientifically correct, like that's how I should put it. But it's fun to watch, and that's why I made it. I hope you enjoyed it, and well, I might have mentioned it before, but I will put up schematics and the code for this if you ask for them. I'm a little bit short on time, so the code is as garbage, just garbage like this. It's working, but it's garbage. So I could make it look nice and make it proper, but I really don't want to do that right now because it takes a tiny bit of my time away that I really should spend on other things. So, like, yes, if you want it, just ask me. If you don't want it, just leave it. And, well, thank you for watching. I hope you enjoyed it. See ya.